send link out. Link out.
In a few seconds, Alan will join us, but I just wanted to tell you a brief introduction about who this person is. So Alan Nichol is a machine learning engineer. He's basically focused on natural language processing. So if you're very interested in NLP, like EWI, and how did I meet? He runs a company, like he has a company called Rasa.NLP. It's basically they help you build like NLP, like if you've been dabbling with NLP, you would have heard of Rasa somehow or the other. Like with.ai, dialogue flow, then .ai, they have your data and help you can build on it. But Rasa took a different approach, like you are in charge, but we'll provide you with the tools to be able to build your chatbot and all. So yeah, he's a super fantastic guy. Like I met him online through one of his Medium articles when I was just getting into NLP. That was 2 years ago when I just joined with him. And I think then I knew absolutely nothing. I remember I sent him an email that I read the article, I didn't understand something. What is UNK? Like what is what you used to for unknown? Like so it was part of that. So I was like, what is UNK? Like thinking back, I felt like that was the most ridiculous question ever. And he took his time to reply to explain that it was this. And since then we still kept in touch, like from when he started Rasa. That was like he wrote that article before he started Rasa, that he was about to start Rasa. It was one name before, then they changed the name. So it's very interesting how rapidly they've grown, and he's a very humble guy, always ready to teach. So if you have questions, all I'm asking of you is to listen to him. He's fantastic. You don't even know maybe he will be your next employer. Rasa is a startup and they're based in Berlin, and they're always looking to hire new engineers and all, but like any reasonable startup, they want to hire the best, right? So you need to take your time to listen to the 2 hours lecture we have with him. Like I'm super excited about this because his article gave room, it inspired my first article ever, and he just made it so simple that to get into the field, and I'm so honored that we're going to have him today. So hopefully it will be, it's online already. I sent him a message already.
He's online already.
He's online. Okay. Yeah?
You saw the young girl.
Yeah?
You know the link.
Actually, yeah, I'm reloading this. Yeah, it's online.
I need the info.
Why am I not allowed to join this call? Look at this place. How would I be allowed to join? Okay, this is the interesting part. I don't know what is happening. Oh, I'm so sorry. It was my other email that I used to.
I'm saying that I still there.
Let me just log into the other. Internet. Who connected you? What do you like? What's the password? Yeah. Two capitals.
6. And you know curly braces? Curly braces. The left one. Left curly braces. 8.
What did you call it?
E4.
E3.
Letter E.
E44.
2 capital C6. Left brace.
Hey guys. Hi. Sorry. Happy.
That made it I don't need any man. I don't need any man.
Yeah, I'm trying to.
Can't take part of your
Let me see if the link works.
That was the point. I know see the black one of the which I didn't find out. No, carry fish.
Yes, this one now. Yes, this one. I need to do this. No, but the neighbor is smart.
That's me. I'm trying to test it. Yes, You know Hamdala, no? Python. Do you know Hamdala? Kiki Jabi.
Oh, are you serious? Why not disconnect? Why not disconnect it? Because all the
Hi. Hi, Helen. Hi. Hey. Sorry, give me a moment. Anyway. What happened to your internet? So you can't, internet is my problem here. Okay. I don't know. It's not connecting. I can't connect to myself. Oh, okay. Your internet is off, I think. Hey, it's not. Sorry. Tim. Meet everyone. Hi everyone. Meet Alan.
Hi. Hi, Alan. How are you today?
I can't hear him. He can't hear you. Okay. Can you hear us? Can you hear me? No, I don't think you can hear me.
Okay, show you. Show you. This one can sleep. Let it
No.
because my network is exploring phone.
Okay. Maybe you should.
One of the last they started it. Sorry.
Sorry. What's the password for you?
Are you shy?
I think it's this internet or something. I still can't
All right.
Wow. So good.
Yes, I know that.
Hi. Oh, finally. Oh my goodness. So sorry. I'm really sorry about that. Okay. Hi everyone. Miss Alan.
Hi, everybody. Thanks for joining.
Thank you for joining us. I'm just telling them about you and how awesome you are. But I would like you to start by introducing yourself, what you do, and then yeah, you can kick off from there. Thank you for joining.
Yeah, sure. So nice to meet everybody. Really cool that you take time with the Saturday to learn about AI. It's really exciting. So my name's Alan. I'm one of the co-founders and the CTO of a company called Browser. And we build open source libraries for building chatbots and voice assistants. So everything around conversational AI. And so I have some slides to show, and I'll give a quick introduction as well about how I got into this position. So should I share my screen?
Yeah. We didn't get what you said earlier, actually. Sorry. we didn't really get what you said. It was breaking up.
Breaking up?
Hello, can you hear us?
Yes, I can hear you.
Okay, I said, could you please repeat yourself? We didn't get what you said earlier. It was breaking up.
Okay. No. Is this any better?
Yes, very.
Yeah. Okay, I didn't change anything, but maybe we're lucky. Okay. So I guess you didn't hear my introduction?
No.
No, okay, no problem at all. So hi everybody, my name is Alan. I work at a company called Rasa, and we build open source. Open source conversational AI. So we build libraries and a framework for building chatbots and voice assistants. And I'll have some slides also to talk a little bit about the story of how we got to starting Rasa as well. So cool, I mean, really nice to meet you all. And what I said before that you didn't hear was, I think it's really great that you will make time on a Saturday to learn about AI and come together. That's like really inspiring. So kudos to all of you.
Thank you.
So I will share my screen. Can you guys see this?
Yes.
Awesome. All right. So I can't speak myself anymore. So I have to talk about maybe to do if someone has questions, then just shout. Because feel free to interrupt questions. I don't want to just talk forever. And just let me know if something. Is that cool? Okay, I'll just keep this. Perfect. And okay, so in terms of outline, I wanted to quickly and talk about how to where we are with Rasa, and talk a little bit about what we do and what we mean by conversational AI. And then I want to talk about what we call the five levels of AI systems. So you might be familiar with the self-driving cars, that there are different levels of what the car is, and it's kind of the same as AI. And I want to go into some technical details, so tell you in level which conversational AI that we do, talk about algorithms and how it works. And then I will talk a little bit about that's happening in what we think really exciting, build the foundation for people free and just kind of where the world is heading. Cool. So I'll start with just a couple of points might be interesting how to use AI. So we started with physics. Actually, I was doing a PhD studying molecules and interactions between molecules. Was one of the ones I think. Using to predict the difference between the atoms in those molecules. And so from physics, I got into machine learning. And then when I was doing my PhD, I met my co-founder, Alex. And we started our first company called Tree. It was Thursday. And what we started was like an integrated search, like search, and search of like Five, Dropbox, Slack, and all this stuff. And we find people for you to share the that you collaborate with. So that was a company, and then we split that and go. I don't remember. Text and then popular textiles, we built the last. And so it was very nice that drop. And okay. And it was we failed, and then the 50. And we were just building some multi-purpose but we spent 15 years building prototypes and doing some consulting for people. What we built was for interacting with the database. Marketing people could post their data and ask about and then they really build the conversation in basically anything, where any good libraries out there. And so that's when we started Raza, and our mission is to build AI assistants that everyone. So I think AI assistants are really what most people do. At the time, we really have a chance to like push things on in the way that it, right? So if I think about like push things on in the way that it, right? So if I think about my grandparents, they kept the internet. I think like, and if I think like technology, my grandchildren, like how far they're going to be. I think we have to think what they how to help you.
Alan.
And but for schools, yeah.
Hi, Alan. Can you hear me? Sorry, it's breaking a little bit, so we could not flow, and then the I can't see your slides anymore. So I think it's from my side, the internet is bad on the computer I'm using to project. So can you give me like 15 minutes so I switch to the one I'm using on my personal computer? It's kind of like a mess, I know, I'm sorry, but just 15 seconds rather. Let me just switch the switch internet so we can flow with you better.
Cool.
Thanks.
It is a shame. That's not fun.
Better?
Yeah, it's a lot better. Thank you.
Okay.
Can you just recap? Okay, yeah. Cool.
So I guess maybe some parts of what I said you missed, but that's okay. So the short version is started another company before that one failed, and then realized that conversational AI was a problem to solve. And then we decided to start Rasa so that everyone all over the world has the tools to build great AI assistants and to really make them work for everyone. And so we don't think that that future is possible if everybody relies on APIs from Google and Microsoft. So there has to be open source tools that people can use and be independent. So the way we do that is by building open source tools, by doing applied research. So of course, a lot of AI happens on archive, and we try to close the gap between what's on archive and what's on GitHub, building libraries that can really build products. and then building the community. So we have a huge browser community. We have 100 different countries. We have nice browser meetups in Mumbai, in Brazil, in New York, in Cincinnati, like all over the world, and I'm with the community, and really work. So a little bit about browser and what I mean by conversational AI. And so what we do at browser is we build two open source libraries. And they work together in this way. So the first library is called Browser NLU. For a voice assistant, what the NLU part does is it stands for natural language understanding. And what it does is it takes a short message and tells you what is the person trying to say, like what is the information in this message. So that's Browser NLU. And then what Browser Core does is it looks at that information, what the user just said, and also everything else that happened in the past, in the conversation, and then predicts what's the next thing I should do. So, you might have looked at something in a database, you might have looked at something in a database, you might have called an API and changed something, found out something about the world. You might need some more information from the user, and of course, conversation can get quite complicated. Everything good?
Yeah.
Everything good?
Yeah.
Something. And it's used by universities and research, it's used by small startups, by NGOs, so really all kinds of people. Yeah. Okay. So what are the 5 levels of AI assistance? So the same way that you have for cars, there are kind of 5 different levels for assistance. At least this is how we think about it. So chatbots are really just the first step. So the level 1, the really dumb level, is just something that tends to push. Level 2 is kind of what we saw years ago when Facebook Messenger opened up their platform. To either expect it to go on or to be something needs to change. And that's the kind of future that we're building towards. Of course, that's very far away still, but technology is kind of on a path to deliver that. And just to take a bit of the mystery out, I'm going to look at the camera for a second. Put your hand up if you saw the Google Duplex demo earlier this year. Okay, a couple of you. Let's see a couple of hands. So Google Duplex is I think, a pretty good example of what we would call a level 3 assistant. So what it does is, on Google Assistant, you can say, hey, can you please book me an appointment for a haircut? And it will phone the hair salon, negotiate times with the person, and all over voice. And it's the text-to-speech quality is really, really high. It sounds very convincing. It can handle all sorts of edge cases where you have to then negotiate different times that might work or don't work. And you can deal with people saying, wait, hold on, give me a second, and some more information. It's a really nice demo. You can check it out on YouTube, and I think it kind of encapsulates what we're aiming for. And the point is that not only Google should be able to build stuff like that, right? So everybody should be able to build something that's that cool. Okay, so that's kind of where we're headed. That's what we try and build you the tools to do. And then I know you guys are all excited about learning about AI, so I wanted to go more into detail of how some of these things work. Feel free to interrupt me with questions. Or if you disagree with something, just point it out. I'd love to hear that. I'd love to hear your opinion. But I'll just talk a little bit about NLU first, and then I'll talk about dialogue. Okay. Like a representation of that should be, right? Someone says my new address is Broadway, and then they're not saying hello, they're not saying entities of the feature that you need to extract from this specific address. You need to be able to pull that out. So just in terms of keeping in mind that, it's a fancy name, NLU, but it doesn't mean that there's any real understanding going on. It just means that you can reliably classify text into one of these intents, and you can extract the entities from there. So, with that said, it's done, right? NLU is easy. So, this is the typical case, right? Someone says something like, I'm looking for a Mexican restaurant in the center of town. You pick up the intent, it's a restaurant search. You pick up the entities, which are that the cuisine is Mexican and the area is the center, and you're done, right? So this is kind of the easy case where everything works with Apple to show. But of course, that's not quite true. Actually, the NLU is hard because language is hard, and people in the way they think is complicated. So one good example is negation, right? So if someone says, no, I don't want sushi, that's easy, right? You can look for the word not, or N_T, and then look for what comes next, and then say, okay, what comes next is negated, right? So do the opposite of that. But then extract, right? That's much more difficult to take on. And you kind of have to know a lot about the world, right? It's not just about natural language understanding, it's really about understanding something about the world that someone would say something like this. And in fact, it seems like a really stupid algorithm to just look for the word not and then look for what comes next. But that algorithm is actually state of the art. So if you look at literature, there are papers where people train, an LSTM or something like that to pick out negation. And then when you look at what it learns, all it ever learns is to look for the word not and then what comes next. So you do a character LSTM, it fires for the word not, then it doesn't fire, and it fires at the next punctuation mark. And if it says between that span, that's where you have a negation. So to do better than that is just really, really, really hard. And then I'd go one step further and say that actually NLU is impossible. So just to give an example of what I mean by that, right? So maybe a quick poll of opinions. Do these two sentences mean the same thing? Can you help me log into my account? And can I give someone else access to log into my account? Right? So in the first, proof of concept of chatbot, you might say that, okay, these are both questions related to logging in. So I labeled these both with the logging in intent, right? But then maybe like 6 months down the line, you have more data, you have more users, and you say, actually, these are different questions, right? And they have different answers. And so you now want to annotate them differently, right? One is a question about getting access themselves. One is about sharing details with somebody else. They're actually different meanings. But, so the point I want to make here is that the question, do these sentences mean the same thing? You might yourself change your mind about them over the course of a single project that you're building, right? So there's no like universally correct way of saying, here's the sentence and here's the intent. It only really matters like downstream, what do you actually want to do with that information later, right? So it's very specific to our application. Another example that I like, and this is taken from Taylor's work on the localization there. So if you consider this sentence, right, the company fired the manager who was hired in 2002. And then you have this one, which says the company fired the manager who's investing money, right? So exactly the same structure. And they're about the same topic, and they're about the same length, right? And tells you what happened with this person, and then it tells you a bit of extra information about them, right? So it looks like they're very similar, but of course, if I say to you, the company fired the manager who was stealing money from the company, like I'm assuming that you are going to guess that there's some relationship between those two statements, right? It's not just a coincidence. Whereas if I just tell you when they were hired, you're probably not assuming that that's why they were fired, right? So that I think we're quite far away from having computers understand why these are such different things, right? Because there's so much knowledge about the world and about society and culture required to understand that. So just, so NLU can be easy, it can be hard, it can be difficult. It's just a question of what you do with the information once you have it. Okay, so I want to talk about classification of intent and the looping. So we launched Rasa NLU almost 2 years ago. And this was the first way that we dealt with intent classification, right? So taking a short message and classifying, whether they're saying hello or goodbye or telling you their address or whatever. So all we did was, well, we take the sentence and turn it into a vector, and then we would train a classifier based on that vector and some annotated examples. And the question then is, okay, well, how do you generate a vector from a sentence, right? So maybe I want to look at the video. Full hands, put your hand up if you've ever heard of word to vec.
What's a vec? You never heard
Can
of
you use word to vec?
What's a vec?
Word to vec? Okay. Couple of people have. Cool. Okay, so word to vec is an algorithm for generating vectors that represent what a sentence means. What a word means, sorry. So the game that you play is you take a whole bunch of text and one at a time you take a word and you read it, and then you look at the words around it and try and guess what's the word that you took out, right? And so the point is that if you have words which occur in the same context a lot of the time, they must have similar meaning, right? This is an old idea called the distributional hypothesis. There's no real reason why it should be true, it just kind of is, right? So if you play this game of guess the missing word, then you generate vectors which have similar meaning, right? If they occur in a similar context. So what you do then is, once you have a vector for each word, then to get a vector for sentence, all we do is we average vectors of the word. And that's probably seems like a very dumb thing to do. There are actually good reasons why it works mathematically. But it's really like the stupidest algorithm you can think of. So you have the word vectors, somebody else produced those for you by training on all of that. You have a bunch of examples, like my new address. You take the word vector for each word, you take the average of the word vectors, and then you train them all. And it just, the classifier, you can use the linear model, you can use the neural network, you can use and what it does is it then, picks out what's the correct intent for any given. The interesting thing is that we ship this model, and of course everybody says, oh, I heard that like deep neural nets are pretty great. Why don't we use deep neural nets? Or somebody says, I learned about nutrition. And actually, it works so you have to get something to work better than that. Just bag of words and a definition. But of course, like any model, it has limitations, right? So one of the limitations is that your word vectors are very generic. And what does that mean? So these word vectors, this game of guess the missing word, and it's things like Google News, guess the missing word, and it's things like Google News, Wikipedia, like large dumps of text from the internet, right? And it's mostly written language, it's about general topics, and so that's reflected then in similarities, right? So the most important property of a set of word vectors is to take related words, how close are the vectors, like how big is the cosine between the vectors. And so if you look here, right, if you think about making a banking chatbot, for example, right, or like a money transfer chatbot, so you can transfer money between friends. So if you think about a word like balance, in context of money or banking, right, balance of course has a lot to do with money and how much money you have. But if you look at what a standard set of word vectors thinks, it thinks that balance is related to words like symmetry and asymmetry and weight, right? Because of course that's like the more common way that we use balance when we talk about things. And similarly for the word statement, right? The statement in regular written English means something that somebody said. So it's very close to the word assertion, right? But in a banking domain, it's more closely related to the word account, and in regular word vectors, those both very, very different. So it just means that if you have some really specific knowledge that's required for your domain, you're not going to get the best performance, and this is kind of where the and the second limitation is just that a lot of words are missing, right? So I'll start from the bottom. The bottom is a typo. Somebody tried to type the word completed, but they missed a letter. So what do you do? Well, you don't have a word vector for this word, right? And unless you do something really clever, you also can't figure out what's the correct word that the person meant. I mean, you can try a spell checker. That will work sometimes. But it doesn't work perfectly. And so just using this, you basically have this information, this doesn't carry any information, right? Another one is slang, right? If somebody uses slang, if you're Google News, then it's not going to know anything about slang. And another one is like if you have really specific vocabulary to your domain. So this word here at the top is a real German word. Did anybody study German in school? That's not how people write. So back we shift a different approach in browser, which is inspired by the star space algorithm from Facebook Research, published about a year ago, and that built then on earlier work with Wasabi. And what the short version is, what you do differently is that instead of taking word vectors that already exist and then training your classifier on them, we get rid of the classifier. We only look at the similarity between the input and the intent, and then we train the word vectors so that the specific ones was like really quite a specific. So sometimes you can get very, very far with using these pre-trained models, but to get like really good performance, once you have enough data, it really makes sense to do something that's more specific. Right? One is this typical video game sort of too. It's a very standard reinforcement learning algorithm, PPO, but they just scale it up, right? And they achieve some really nice results on language understanding as well, where they train the model, and it's again something that's like well known and understood. It's kind of unsupervised training using transformer, which is like a well-known architecture for machine translation. And they train this model on 8 GPUs for a month on like a huge number of nodes. And it produces these beautiful, really impressive sentence vectors, which capture a lot of important meaning. And so that's a really cool trend that, the things that are already known, the ideas that are already out there and we know work, still have a lot to offer.